This is U.A.C.E taking you through trigonometry, and in this video we are going to be tackling compound angles. Now this video is presented to you by U.A.C.E and you're advised to subscribe to the channel and share the video to your friends so that you can all benefit as a family. Formulas for compound angles are as follows, but there was a typing error in tan A minus B and tan A plus B. But the others are okay. We are saying that sin A plus B, if you are given any expression, trigonometry expression in form of sin A plus B, is going to be sin A cos B plus cos A sin B. Now all these formulas are availed in your mathematical logbooks, and you are allowed to move with your mathematical logbook in the examination hall. And then sin A minus B is going to be equal to sin A cos B, then minus cos A sin B. Now what you should note here is that for the case of sine, the signs don't change. If you're having addition signs here in the bracket, it remains the same after expanding. Similarly here, A minus B, after expanding the expression, you remain with the same sign. But this is going to vary when we go to the cos functions. As you are seeing here, cos function here, A plus B, is going to be the same as cos A cos B, then less sin A sin B. Now here in the bracket you have addition sign, but after expanding, it turns to negative. Also here, cos A minus B, here you have subtraction sign, but after expanding, it becomes positive. So that's the main important part about sine and cos. Always don't forget. Now tan A plus tan B is the same as tan A plus tan B divided by 1 minus, this is supposed to be multiplication, or it's supposed to be the product of tan A and tan B. Similarly to tan A minus B will be equal to tan A minus tan B divided by 1 plus tan A multiplied by tan B. This is not addition sign. Now, both of these ones can be proved or they can be derived, but these ones can only be derived, they cannot be proved. So let's look at the examples involving compound angles. Now in the previous video, I taught you how to find special angles. 45 degrees, 30 degrees, and 60 degrees. So here you're going to be given expressions in form of compound angle, or you're going to be given angles that require you to first express it in terms of compound angles, and then you expand them in terms of special angles, and then you turn everything according to the triangle that I gave you of special angles. Now that triangle should be on your fingertips. If you didn't watch it, you're advised to go back to the previous video and you'll watch it fully. Now you're seeing that examples. Now part A, we are going to be solving cos of angle 45 degrees less 30 degrees. And part B, we are going to be solving cos of 105 degrees. And part C, we shall be solving cos of 75 degrees. Then in part D, we shall go to 60 degrees plus 45 degrees. Now notice that all these expansions are special angles. All your expansions that you are going to use must be in terms of special angles. And with the special angles, just like I said in the previous video, I told you these ones are 60 degrees, 45 degrees, and 30 degrees. Every question is going to be, you must expand it in terms of compound angles. To get part E is telling you to find sine of 15 degrees. Now let's look at how that can be found. Look at part A, they gave you to determine or to find the solution for cos 45 degrees less 35 degrees. Now here, notice that this is in terms of, if we put this in terms of compound angle, our A is going to be 45, and then our B is going to be 35. Now if you pull out your logbook, or if you remember this expansion in your head, we told you that compound angles for cos, this sign changes after expansion, and also it's the same as cos A cos B, then plus sin A sin B. But in this case, our A is 45 degrees and our B is 30 degrees. So you substitute them appropriately. Now you go back to the triangle that I shown you. Now for 45 degrees, I told you use a right angled triangle. Now this right angled triangle has angle 45 here. So that means that here is your theta, or angle 45. Now this is a right angled triangle. That means that we have angle 90 in this corner. And I told you that this is going to be 1 and then this is going to be 1. And we get hypotenuse by getting 1 squared plus 1 squared. And then you're going to be getting root 2. So how do we get cos of 45? Now cos is equal to adjacent over hypotenuse according to second law. That's why we are having 1 out of root 2 here. Then what about sine? If you look at this one here, sine is the same as opposite, which is 1, divided by hypotenuse, which is root 2. That's why we are having 1 over root 2 here. Then what about cos 30 degrees and sine 30 degrees? Now if you go back to the previous triangle that we drew earlier on, I told you that for special angles, here we are going to be having root 3. And then here you're having 2. And then here you're going to be having 1. Now angle of every vertex here contains 60 degrees. Now since this one upwards is divided, that means that one angle here is the same as 30 degrees. So how are you going to get cos 30? Now since cos is equal to opposite divided by adjacent, or adjacent divided by hypotenuse, we are going to have to get cos 30 here. If you look at this is going to be our root 3 is going to be our adjacent, and then our hypotenuse is 2, and then our opposite is going to be 1, just like I explained in the previous videos. So cos 30, we get our adjacent, which is root 3, divided by our hypotenuse, which is 2. That's why we are having root 3 divided by 2 here. Now to get sine of angle 45 degrees, I've already mentioned how we get that. Then we get sine 30. Now if you look at sine, I say that this is going to be our opposite. And sine, according to Sakatoa, is equal to opposite divided by hypotenuse. So this is going to be 1 divided by these 2. And then you'll be getting 1 over 2. Now the rest is simplification. You first multiply and then you're going to get this. After this, you correct LCM, which is going to be 2 root 2. Then you just add the numerator, which is going to be 1 plus root 3 divided by 2 root 2. But in pure mathematics, we do not leave a root in the denominator. So how do you remove roots in the denominator? We always do that by rationalizing. That's why we rationalize 2 root 2 here. However, also another student can just rationalize root 2 only. Root 2 and root 2 here, but here I rationalize everything. I multiply 2 root 2 both in the denominator and in the numerator. Now for roots, there is no change in signs. You leave it the way it is. We only remove roots by multiplying them with the root of their own number. So that's how we rationalize for roots. Now after rationalizing, you're going to end up with this. After this, you're going to simplify. You're going to see that this 2 is going to go away, and then you're going to remain with 4. So your final answer is going to be root 2 plus root 6 divided by 4. Now going on to the next part, which is part B. Part B that I've told you. Now part B is 30 degrees plus 45 degrees. Now notice that here I helped you separate these things. In most cases, we are not going to be separating them. So you expand. I told you, according to compound angle, this is the same as angle A, and then this is the same as angle B. So sine A plus B is the same as sine A cos B. Then for sine, the sign remains the same. We don't change it. Then cos A sine B. But here our angle for A is 30 and our angle for B is 45. And you do the same also this side. Now notice that I told you, for such calculations, you are going to be dealing with special angles, and I told you that you should know these special angles, their derivation. Special angles are always going to be 30 degrees, 45 degrees, and 60 degrees. You should know how to express them in terms of fractions using the triangles that I taught in the previous video. So you find that sin 30 according to this triangle is going to be 1 over 2. Then cos 45 according to this triangle is going to be 1 out of root 2, just like I've explained in the previous part, which is part A. Then plus cos 30 is going to be root 3 divided by 2 according to this triangle, because adjacent is root 3 and hypotenuse is 2. Then multiplied by sin of 45 is going to be 1 divided by root 2. 45 is got by this right angle triangle. Let me hope you understood how it works. So in simplifying, you are going to get 1 divided by 2 root 2, then plus root 3 divided by 2 root 2. Now you find the LCM, which is going to be 2 root 2. In the numerator, you are going to remain with root 3 plus 1. Simplifying, you are going to end up with this answer. Now we go to part C. If you see part C, now this is how we are going to be setting those questions. We give you an angle, a single angle, and we tell you to simplify it. But to simplify this angle, it's going to require you to combine to find two special angles that you can either add or subtract to give you that very angle. Now if you look at 100.05, if you are to get any special angles, the special angle set that we are having is 30 degrees, 45 degrees, and 60 degrees. So which of those angles we can add or subtract to give us 105? So I found out that we can get 60 degrees and 45 degrees. Now the reason why we place them this way is because we solve such questions using compound angles, where 60 degrees is going to be our A and 45 degrees is going to be our B. So expanding cos A plus B, I told you the sign changes from plus in the bracket to negative after expansion. So it's going to be cos 60, cos 45, then minus sin 60, sin 45. Now you substitute, cos 60 is the same as a half. Now for the special angle of 60, just like I told you, each vertex of this triangle contains an angle of 60. Now in the previous one, we divided this angle of 60 and we got 30. That's how we got this up triangle. But here we are going to use the 60, which is here. Now once we use the 60 degrees, which is here, that means that this side is going to become our adjacent, which is 1. And this is going to be our opposite, which is always root 3. And the hypotenuse is always 2. So how do you get cos 60? Cos 60 is equal to adjacent divided by hypotenuse. Our adjacent here is 1, hypotenuse is 2. That's why you're having a half here. Then cos 45, you use this first triangle that I told you. You're going to see that it's going to be 1 divided by root 2. So this is done. Then sin 60, if you look at this triangle, sin 60 is equal to opposite. Now our opposite here is root 3 divided by hypotenuse, which is 2. So that's why we're having root 3 divided by 2. Then multiplied by 1 divided by root 2. Now here, this is sin 45. Let me hope you understood how we get that. Now you simplify and you're going to get each of them having a LCM of 2 root 2. Now after finding LCM, you simplify. Now look at this. After finding LCM, we remain with a root in the denominator. So how do you eliminate that root? You multiply that root by its root. So we call that rationalizing of sides. We don't leave sides in the denominator. So multiplying by root 2 on both the numerator and denominator, you're going to end up with root 2 minus root 6 divided by 4. Now let me hope this has been clear. Since you have understood how we get the angles, let me just pass through them. Now to get 75 degrees using special angles, we can get 75. 75 is not a special angle, so we change it to special angle so that we can use compound angles. So 75, from the special angles that we have, I told you the special angles we are having is 30, 45, and 60. So how can we use any of those two angles to either add them or subtract them so that we can get 75? Now you find that 75 can easily be got by adding two special angles of 30 degrees and 45 degrees. And then you choose them. Now the other procedures remain the same. Expand according to cos and then substitute according to the triangles that we have already discussed. When you get a side in the denominator, you have to rationalize by multiplying it through. Now I told you can either multiply the whole figure of 2 root 2, or you can just multiply a root only, root of that number, and then you end up with root 6 minus root 2 divided by 4. Now if you go to part F was already simplified. All you need to do is expansion. After expansion, you substitute. On substituting, you find LCM. If you remain with the side in the denominator, you rationalize by multiplying through by the root of that number, or multiplying through by the whole number, both in the numerator and denominator. Then you end up with this. Your final answer should not contain a side. If you go to part F they have told you to find sine of angle 15 degrees. Now which special angles can you use to get 15 degrees? Because 15 degrees is not a special angle. That means that we have to get two special angles that we can either add or subtract to give us 15 degrees. And if you find those two special angles, you're going to see that you may have 45 and 30. Now expanding them is going to give you this. You substitute according to the triangles. This is where you get those values, and then find LCM and simplify by multiplying through by root 2 to eliminate the side in the denominator. To the next example. Now in this example, you have to be very keen. In this example, you are going to be given values in terms of fractions, and they are going to tell you that either of those angles is either acute, reflex, or obtuse. Now, for any angle to be acute, to solve such numbers, we follow the principle of here in this first quadrant, all components are positive. Now, in the second quadrant, only sine is positive. Now, in the third quadrant, only tan is positive. Now, in the fourth quadrant, only cos is positive. So that means that if they're telling us that our angles are lying between the first quadrant, that means that all trig functions must be positive. Now what you should take care of in this, when you're solving this kind of questions, the most reason why many of you lose marks or are going to lose marks is that you don't show this simplification, which must be shown. You just skip and you just write values here, writing everything on your calculators. Now that's very wrong. You rather write the last step. You show how you are going to be getting either of these values that are not given on your curve. Now here you have been told that you're having two angles. Now since you're having two angles, that means that you have to have two triangles. You need to sketch two triangles aside because they cannot be on the same sketch. Now sine A, remember that sine according to SOHCAHTOA, we told you that according to SOHCAHTOA, sine is the same as opposite divided by hypotenuse, and cos is the same as adjacent divided by hypotenuse. Now similarly to tan is equal to opposite divided by adjacent. Now that's how we name this. That means that sine A, they told you that the angles are acute. That means that they all lie in the same quadrant. Now when you're sketching these triangles, because this is very important, when you're sketching these triangles, you make your sketches you draw vertical lines towards the horizontal axis. Many of you confuse this and you draw sketches like this, which is very wrong. For you to draw a sketch, your vertical line must be towards the horizontal. So that means that this is the triangle we expect to be drawn in the fourth quadrant. And in the first quadrant, you get your ruler, you draw vertically towards the horizontal axis. So that means that this is the triangle we expect in the first quadrant. Now to get the second one, you draw a line still to the horizontal axis. Every sketch you do, it must be from your diagonal line to the horizontal axis. That's how you sketch these triangles. Now always the angle is around the center of that compass that you are using. Let me hope that has been very clear. Now to go here to proceed, you have been given that sine A is equal to positive. Now since they're acute, they all have to be positive because we can't have acute angles. Acute means 90, angle 90, and angle 90 lies between the first quadrant. And for the first quadrant, all trig functions must be positive. That means that for every answer that you get, we expect it to be positive. Now, first of all, you sketch. You are given that sine A, angle A is going to be here. I told you its always towards the center. Sine A is equal to opposite, which is 3, you label it. And then hypotenuse, which is 5, you also label it. Now, they didn't give us the adjacent, which you have to find. Now, how can you find adjacent? Now, here you can either show this. Now, here I just shown you an elaborative step. You can compress all that here, and you say that x is going to be good by getting 5 squared less 3 squared all under a root. Therefore, you end up with 4, just like here. Now here, you sum up after getting square root, always the answer is equal to positive or negative. But here we don't want any negative. You always consider only positive answers. Now similar to B, they gave you sign still, which is opposite. You label it as 5. Hypotenuse, you label it as 13. And then they didn't give it adjacent, you give it an unknown letter. And then you show how this adjacent is going to be obtained, because there is a bonus mark for it. The formula for finding this unknown value, there's a bonus mark for it, and I told you most of you lose marks just because you skip that step. Now that you have found the adjacent sides of both, we can now go ahead and solve the expressions that we are given. Now for these expressions, they were given in terms of compound angle. That means that we cannot do anything before bringing in compound angles substitution. Now I told you that compound angles, it's advisable to know them in your head as expressions by doing numerous practice. Or you can buy a logbook and you enter with it in your examination hall. Simplification. After finding one of the sides, you are advised to find all trig functions of that angle, sine, cos, and tan. So after finding our adjacent, sine was given, which is equal to 3 over 5. Our 3 was the opposite, 5 was the hypotenuse. Now cos is equal to adjacent divided by hypotenuse. And our adjacent, we calculated it to be 4, which is there, and then divided by hypotenuse, which is 5. Now tan A will be equal to 3 over 4, because tan is equal to opposite divided by adjacent. Now for sine B, it was also given. You also find other trig functions of cos and tan. For cos is going to be 12 over 13, and for tan is going to be 5 divided by 12. Now for sine expansions is going to be equal to this. According to compound angle, I told you, you cannot just substitute angles here. Whenever you have something like this, they want you to first use compound angles. Now using compound angles, you're going to end up with an expression like this. Now after expanding, all you have to do is substituting what you already have above. Now after substituting, you're going to end up with 36 divided by 65 plus 20 divided by 65. Now here you find LCM, which is going to be 65, and you add the numerator, which is going to end up as 56 divided by 65. Now for these questions, you are advised, since the question gave you values to use in fractions, you are also advised to leave every answer of yours in fractions. If the question gives you things in points, you are also advised to give your things in points, or your final answer in points. Now for cos A plus B, you just need to expand this one to compound angle. And I told you for cos, if the inside bracket has positive, after expanding, the sign changes to a negative. Now the other thing after expanding is going to be substitution. So substituting is going to give you this. And then simplifying, you're going to end up with this. Correcting LCM, which is 65, you're going to have 48 minus 15, and then you end up with 33 divided by 65. Now your part C, you're being told to calculate for cot, but remember that cot is not a standard element that we have in compound angle. But as we started, we said that cot is always the reciprocal of tan. So that's what we first do. We put it in a formula that can be calculated, or that has a compound angle expansion. Now that we know that tan is equal to this, we bring it and we substitute it here. Now notice that when we substitute it here, it's going to be the reciprocal of this. That's why this one comes in the numerator and this one goes in the denominator. Now after doing so, the other thing is to just substitute. Substituting is going to give you this. Simplification is going to bring you here. Now you're going to end up with 33 divided by 16 and everything divided by 7/6. Now you get reciprocal of this one and then you end up with 33 divided by 16 multiplied by 6/7. Now you're going to end up with 99 divided by 56. Now if you go to example 3, you are being here the term they have used. Now what you should pay more attention is which angle are they telling you. Now they have told you that A is obtuse. Obtuse, that means that it's 180. That means that it is lying in the second quadrant. Now what is about the second quadrant? We say that here they are in the archute, they are all positive, but in the second quadrant only sign is positive. That's why when they gave an expression of sign here, they gave it as opposite. But for you, when you're simplifying, that means that for any trig function that you are going to get of any angle lying under this quadrant must be negative. You should put that negative sign there. And here they told you that B is archute. That means that B is in a place where every trig function is archute. So finding any other trig function of B must be positive. So I say that since you're having two angles, you have to have two sketches. Then after having those two sketches, you label them. Sign which was given is the same as opposite, which is 4 here, and divided by hypotenuse, which is 5. And I told you how to sketch. You do a diagonal line, and then you draw your vertical line towards the horizontal axis. Now you do the same with angle B. Now angle B, it is archute, that's why our sketch looks like this. Now these sketches have a particular way to look. Every sketch you draw, it must be in line with where that trig function lies. A, they told us, is obtuse, that's why it's lying in the second quadrant, and its sketch is going to like to be appearing like this. And then B is archute, that's why its sketch is appearing like this, because it's in the first quadrant. Now they didn't give us the values of adjacent in either of them. So what do we do to get adjacent? I told you have to share formula because it's given a mark. Sometimes we give it 2 marks. And then students tend out to miss out such marks when they are trying to do everything on the calculator. Here we are not marking content, we are marking how organized you are. So you find that X is going to be 3 and then P is going to end up with 5. Now after finding those values, I've told you after you find other trig functions, if you're having sine, you find cos and tan. If you're having cos, you find sine and tan. So let's find sine. Now here in the question we are given for sine only. So let's find cos A. Now since here in the second quadrant only sine is positive, that means that other values of cos and tan must be negative. All other trig functions must be negative. So you first write that cos is equal to adjacent. Adjacent, we have got it as 3 divided by hypotenuse, which is 5. But here we are putting this negative sign because cos in that region is negative. Now we also get tan. Tan is equal to opposite, which is 4 divided by adjacent. But you have put this negative here because tan in that region is supposed to be negative. So the negative is just brought and you attach it there. Because in this quadrant of A, only sign is supposed to be positive. Now we do the same to B. Now for B, it is in the archute side, and in the archute side, all trig functions must be positive. That's why you're not going to see any negative sign anywhere. So when you're having sine of B is equal to 5 divided by 13. Now cos of B is the same as 12 divided by 13. And tan B is equal to opposite divided by adjacent, which is the same as 5/12. Now you are being told to solve sine A minus B, and I told you this is in terms of compound angle. Remember that when you're expanding signs remain the same. In the bracket also remains the same after expansion, but for cos they change. Now sine A sine B, sine A minus B is the same as, according to compound angle expansion, is the same as sine A cos B, then less cos A sine B. Now since you already found all these, you just substitute. Now substituting is going to give you this. Simplifying, you're going to get 48 divided by 65 plus 15 divided by 65. Now we are given our things, the question presented our values in terms of fractions. That means that we leave everything, also our answers, in terms of fractions. So this is going to be 63 divided by 65. Now we go to tan A minus tan B. Now here you first expand by compound angle. Tan A minus B by compound angle is the same as tan A minus tan B, then divided by 1 plus tan A tan B. Now here you substitute. Substituting, you simplify, you are going to end up with negative 63 divided by 16. You do the same thing to tan A plus B. Tan A plus B is the same as tan A plus tan B divided by 1 minus tan A tan B. Then you substitute, simplify, and then you are going to end up with negative 33 divided by 56. Now you make sure that you bracket your work to ease simplification. For example 3. Example 3, they told you that cos A is equal to 3 over 5 and tan B is equal to 12 divided by 5. Now they told you that A and B are going to be reflex angles. Now for reflex, remember that this is acute, this is obtuse. Now for reflex, it depends. Here only tan is positive and here only cos is positive. Now once they give you values that are positive, for reflex means everything down here. But for you to sketch a triangle, you should look at the values given. Like here they gave you tan and they gave you a positive value. That means that tan is only positive in this quadrant. If it was a negative and they say that it is reflex, then you would have put it here. Let me hope you have understood that science, because here only cos is positive. But since they said it's reflex and they gave it in positive term, that means that it's lying in a quadrant where tan is positive, which is this one. So the sketch for tan B, or for angle B, is going to be under the third quadrant. And we say that drawing that triangle, you draw a vertical line from your diagonal towards the horizontal. The moment you put it on the vertical axis, you are going to get everything wrong, because you can't have a wrong sketch and you give us correct results. However much results they are, but if your sketch is wrong, you are not awarded any mark. Now here you are given tan B. So tan B, you label it, since it was in positive, tan is positive in the third quadrant. You put it here. Now here, tan is equal to opposite. Opposite is 12. Divided then adjacent, which was 13, divided by adjacent, which is 13. Now they didn't give us 5. Now I didn't show you get 5 here, but I've told you if you don't show that, you are going to be penalized. How do we get this 5? This 5 we get it by saying 13 squared minus 12 squared, everything under root. So you have 169 minus 144, everything under root, you remain with root of 25, which gives you 5. Now if you go to cos A, now cos was given as a positive value, and you say that cos is positive in the fourth quadrant. That's why when you're drawing this triangle, you draw from the diagonal to the horizontal, and that's why sketch is appearing like this. Sketches are very important because they determine what you're going to write. Now since cos is lying in this third quadrant, we are going to label it, and it was given in positive. That means, and it's a reflex. I told you reflex means everything down here. But where you are going to sketch a triangle is going to determine whether they are giving you a value which is negative or positive. So cos, since it's positive, cos is positive only in this region, and tan is positive only in this region. That's why the sketch for tan was good from here, and the sketch for cos was also good from here. So cos is the same as adjacent, which is 3, divided by hypotenuse, which is 4, divided by hypotenuse, which is 5. Now how did you get 4? I told you have to show that formula. It's going to be 5 squared minus 3 squared for you to get 4. Now you get angles. Since cos A was given as 3 divided by 5, you get other trig functions. Now in this quadrant of cos, remember that I've told you only cos is positive. That means that other trig functions must all carry a negative. That's why when you're getting sine A, which is opposite, divided by hypotenuse, is going to be negative 4 over 5. Tan the same thing, which is going to be negative 4 divided by 3. tan is equal to opposite divided by adjacent. Now for B, if you look at angle B, now for B here, in this quadrant, in the third quadrant, only tan is positive. That means that other trig functions are going to carry a negative. That's why when you're getting cos A cos B, we are going to say it's negative 5 divided by 13. Sin B is going to be negative 12 divided by 13. And tan B is going to be 12 divided by 5. A minus sin B. Sin A minus B, you expanding by compound angle gives you this. Now the rest remains substitution. Simplifying gives you 20 divided by 65 plus 36 divided by 65. Simplifying gets you 56 divided by 65. Now for tan A minus B, expanding by compound angle gets you this. Then substituting, you have this. Then you have negative 56 divided by 15, everything divided by negative 11 divided by 5. And then you're going to end up with 56 divided by 33. Now expanding cos by compound angle gives you this. Now substituting gets you this. Simplifying you get, now remember that all these ones you got them, that's why I'm not wasting time. It's a matter of substituting what you already got above. This is negative 15 divided by 65, then minus 48 divided by 65. You get negative 63 divided by 65. Now I told you when they give you your values in terms of fractions, the values chosen in terms of fraction in the question, you should also leave them in terms of fractions in your answers. To handle some of the standard questions set numerously in the question bank. Now here you are being told to solve expressions that are also in the same as compound angle. Now what you do here, whenever you see such anything that requires compound angle expression, is what you expand first. But you should pay attention of the coefficients like this one, because this coefficient must affect all your expansion. Now some students, they don't see that and they lose marks from there. That's why I gave it as part A. Also here is present in part B, so you have to pay attention to that, because that's how we are going to reduce the number of students passing these papers. Alright, so going to the solution for part A. Part A is going to be sine of x plus 45 degrees being equal to cos of x plus 45 degrees. Then we expand by compound angle. Compound angle expansion of compound angle by sine is the same as sin x cos 45 degrees, then plus cos x sin 45 degrees. When you expand in cos, this 2 is going to affect the expansion. So you bring in a bracket. You bring in brackets. So, and you expand this one alone. Cos x plus 45 degrees, according to compound angle expansion, is going to be cos x cos 45 degrees, then minus sin x sin 45 degrees. But remember that these ones are special angles. I told you whenever you're having a trig function of a special angle, you always substitute for it in terms of fractions. And I told you special angles are not many. 30 degrees, 45 degrees, and 60 degrees. So here you are going to end up with sin x divided by root 2, then plus cos x divided by root 2. Here is the same thing, substituting for special angles, which you do by triangles, which I'm not going to repeat here, but you should do it as your side work to see how I ended up with this. Now here you are going to end up with root 2 divided by 2 sin x, root plus root 2 divided by 2 cos x. Now 2 into bracket of this. Now remember that I told you this 2 affects every expression. So when you're opening up this bracket, that means that 2 is going to multiply this one, and it's also going to multiply this one. So multiplying 2 throughout, you're going to end up with this. Now correcting terms having sine, you correct terms having sine and terms having cos together. So correcting terms having sine, everything containing sine, I bring it this side. So this one is going to be positive. Now remember that if it becomes positive, I prime factorize out sine because it's going to be common. So I remain with root 2 divided by 2 plus root 2. Everything prime factorizing out sine. Now we do the same to cos. We correct terms of cos together. So we leave root 2 cos x this side, and then you bring this one this side, which will turn into a negative. So it will be minus root 2 cos x. Now here you do the same. You prime factorize out cos x. So it's going to be root 2 minus a half root 2. Now this is the same as like when you're subtracting roots, you don't deal with the roots. You only consider their coefficients. So the coefficient here is 1, so it's like 1 minus a half, which is going to give you a half root 2. You don't subtract roots. You just find LCM, which is going to be 2, and this is going to be 1. So it's going to be 2 root 2 minus root 2, and then you end up with a half root 2. This side you're going to end up with, this is going to be a half plus 1, which is here. You only add the coefficients. You deal with the coefficients for the case of roots. So a half plus this one here, you're going to end up with 3 divided by 2, and it's going to multiply your root 2. So you end up with 3 root 2 divided by 2 sin x is equal to root 2 divided by 2 cos x. Now here you correct trig functions on one side and then also values on one side. So we shall divide through, first of all we shall multiply through by 2 so that these two cancel, and then root 2 will also go. Now we remain with 3 sin x being equal to cos x. Now correcting trig functions on both sides, we shall divide through by cos x. Dividing through by cos x gives us this. And sin x divided by cos x gives us 3 tan x being equal to 1, because this one and this one cancel out each other to give you 1, not 0. So making tan x the subject, you're going to have 1 divided by root 3, tan x being equal to 1 divided by root 3. Now here in the question, they told us to find the values of tan x. That's why we didn't find the angles. But also finding angles was discussed in this very channel. So you are allowed to proceed and find those angles and then test them out to see whether they are truly correct. Now here, another way to solve this, after reaching this expansion here, someone here can divide everything throughout by cos x. After expanding and after simplifying in linear form, you divide through by cos x so that you can get your tan easily, and then you correct your values on one side and you correct trig function on one side, which is going to be in terms of tan. But part D is giving us this. Now it has a coefficient. I told you have to be very aware of this. Now for that coefficient, you put your expansion in a bracket and then sin x minus 45 according to compounding expression gives you this. You also expand cos, which is also expanded according to this. Now since this is a plus, this one becomes a minus. Now since 45 is a special angle, you first convert your trig functions having those special angles in terms of fraction, which is this. Now you have to show substitution and then you simplify, because substitution is going to carry a mark, which is bonus 1. Now simplification is going to bring you here. Now I've told you here, you first make it linear. After making it linear, you end up with something like this. Now here you have two options. You can either divide through by cos, or you can simplify and correct everything having sine on one side and everything having cos on one side. You have two options here, either to divide through by cos so that you can get your value of tan easily, and then you correct values on their sides and you remain with the trig function on side, or you can correct trig functions of the same trig function at one side and the others at the other side. So trig functions containing sine are going to be this side, and trig functions containing cos are going to be this side. So simplifying, prime factorizing out sin x, you're going to have root 2 plus a half root 2, which you're going to end up with 3 divided by 2 of root 2. And I told you, when you're adding roots, you only consider their coefficients, you don't add roots. So the coefficient of root 2 is 1, and the coefficient of root 2 divided by 2 is a half. So 1 plus a half is equal to 3 over 2. That's why you're having here 3 root 2 divided by 2. And the same thing this side. Now these ones are going to go since they're the same, and then you just divide through by cos x. Now once you divide through by cos x, everything is going to cancel this side to end up with 1. And sin x divided by cos x is going to give you tan x. Now here you are going to use the same idea. Whenever you are given these expansions, you always think of compound angle. Now doing that, you're going to have this. Now simplifying, because they gave you that tan A is the same as 2. So substituting, you have this. Now for easier solving, you're always supposed to make everything linear. After making everything linear, you open up the brackets, which you end up with this. Then you correct values of tan on one side. So you bring tan this side, and then you take 3 this side. So this will be -4 minus -3 to end up with -7. Now this will be 6 tan x plus 2 tan x minus 2 tan x, you end up with 4 tan x. So remain with tan x being equal to -7/4. And I've already taught you how to find angles in this channel, which was the first video. So review it and you see how you can find all these angles. Now you got part D. Part D is the same idea. Expand. Now 30 is a special angle. That means that you have to substitute for it first. Then here you have two options. Either you divide through by cos at this level, or you can correct functions of the same trig functions on the same side. Sine, you put it on your left hand side, and also cos, you put it on your left hand side. Now you prime factorize out cos, and then you add the coefficients. So it's going to be root 3 minus half. You're going to end up with this after finding LCM. And then this is going to be root 3. After prime factorizing out sine, you're going to end up with root 3 divided by 2, then plus half. You're going to end up with this. Now we correct trig functions on one side, so we divide through by cos x. So it's going to be you are going to end up with this expression. We also divide values. We take values on one side. Now these two and these two are going to cancel out. You are going to end up with this, but we don't remain with a third in the denominator. That's why you rationalize. So simplifying is going to give you tan x being equal to 2 minus root 3. So the idea, and now here what I'm going to focus at is I've also told you to find the angles, and I've given you this range. I've told you I taught expansively on how to find angles. So part A, solution for part A, just like we have been describing, whenever you see a compound angle expression that needs to be expanded, you start with that. Now since 60 is a special angle, you substitute for it, which is going to be root 3 divided by 2. Sin 60 is going to be root 3 divided by 2, because 60, if you look at the special angle triangle, we saw that for 60 degrees, here lies 1. Now here is root 3, and here is 2, and the angle lies here. So since sine 60 is equal to opposite divided by adjacent, it's going to be our opposite is root 3 divided by hypotenuse, which is 2. Now for cos 60 is going to be 1 divided by 2. And then when you see that it's a special angle, always substitute for it first. And then you either correct terms having sine on one side and you leave cos on the other side, or at this same level, you can divide through by cos x on all angles to end up with tan already, because that's the main purpose of compound angle expansions. But here, I made it easy for you so that I corrected sin x on both sides, and I remain with this expression. So you prime factorize out sin x, you're going to remain with 2 plus root 3 divided by 2, and then you're going to end up with this. Now you multiply through by 2, this half is going to cross with the 2 that you multiply through. Then you're going to end up with this expression. Now you divide through by cos, and this side you divide through by the value to get tan x. And now you're going to get tan x being equal to this. Now you put everything in the calculator, and then you find values of your angles according to the way I explained the first video. I overspent time there. So you see whether you try to test out whether you can get these angles. If you can't, refer back to the first video. Now going to example B, you expand by compound angle this expression, you end up with this. Then you correct after seeing special angles. 45 is a special angle, you substitute for it, and then you're going to end up with these expressions. Now these expressions, notice that they are going to give you 1 divided by root 2, but I told you we don't leave root 2 in the denominator. So how can we simplify this? By multiplying through by root 2, both the denominator and the numerator. So you end up with root 2 divided by root 2 times root 2 is the same as 2. So 1 divided by root 2 can also be written in this form. That's why you're having these ones here. because I didn't want to have sides in the denominator. Now you make everything linear, then you correct terms. For cos on one side, I told you here you have two options. You can either divide. Now this cos is not there. You can either divide through by cos from here so that you can go straight away to tan, or you can correct terms of cos on one side and terms of sine on the other side. You prime factorize out and you add the coefficients. But I feel like dividing through by cos was a better option. Though I provided this. So you prime factorize out cos, then you're going to remain with root 2 divided by 2 plus 1. On the side of sine, you're going to remain with root 2 divided by 2 sine x. Now you divide through by trig functions in such a form that is going to allow you to get tan. So that means that you have to divide through by cos x, which is always. So you have sin x divided by cos x. And these values, after dividing, these two and these two go away. And then you're going to remain with root 2 plus 2 divided by root 2. Now this expression is going to give you tan. And to find your angles according to the way I've explained in the first videos, they must be in this form. Now use this video as a practice video to see whether you can get these angles. Scaling part C is going to be in this form. Expanding is going to be this. That is a special angle. You substitute for it, making everything linear and correcting cos on one side. This is going to be half plus a half. That's why you end up with cos x here. Then you divide through in such a way that is going to get you tan. Or you can divide through by cos from this level too. Then you're going to have sin x divided by cos being equal to 2 divided by root 3. Then tan x is going to be equal to this. Simplifying and getting the angles, they must be this. And I've told you I'm not going to teach how to find angles because I taught how to find angles in the previous video. Now if you go to part D, you're going to have this. When you're expanding, when you have coefficients, you always introduce brackets. Now expanding on the other side, you're going to end up with this. Now you correct terms of sine and cos on one side, then you're going to end up with this. Now we only correct the terms having known angles, they are not considered to be unknowns. So that's why you classify them together, but do not find their values before reaching the final step, just like I did here. So I prime factorize out sin x and I prime factorize out cos x. You divide through to get tan x, and then you're going to end up with this. Finding angles, they must be this, according to the required range. It's supposed to be your exercise. You find out how I got this. This is a compound angle expression. You expand. Once you're having a standard value, you always refer back to that angle of 45. Now here is 1 and 1. That means that tan 45 is going to be 1. You make your values linear. You correct tan on one side. You are going to end up with 3 tan x being equal to 1. You make tan x the subject, and you are going to end up with a third. Now here they didn't require to find the value of x, but in the questions of the question bank, you'll be required to find the value of x. Now this was supposed to be an assignment too, but I helped you and I gave you the values. But you can test out yourself and you see whether you end up with this, as I'm not going to explain it. In example 4, you're having solutions and you're being prompted to find out the values of either of the components. Let's see how we can deal with that. These ones are very rare questions. It's just a brain teaser or to bring you up, but it can be rarely examined. It requires to reverse the fractions that you are given back to their special angles. So we can get a half by cos 60, and we can get 3 divided by root 2 by sine 60. Then you substitute them there, and then you find that which trig expansion gives you this. Under compound angles, you find that that will be cos of 60 plus x, and therefore the required expression would be this. Now going to this, root 3 is the same as tan 60, then this is tan x, then divided by 1 minus tan 60 tan x. Now if you look at this expression, it's the same as angle of tan a plus b, which is, and our a is going to be 60, our b is going to be x. That's why you're ending up with 60 plus x. Now here, 1 out of root 2 is the same as sin 45, and 1 out of root 2 is the same as cos 45. Now this expansion here, compressing it back is the same as cos of 45 minus x, which was required. Now going to this one, if you look at this expansion very well, now how can you identify that this expansion has to be brought back to its simplest form? When you are seeing that angles are repeating, are you seeing here we're having 24 and you're having 24 here, we're having 15 here and you're having 15 there. That means that such expressions are going to be requiring you to compress or to recompress the expansions so that you can get a clear view. So compressing that, we shall have cos of 24 plus 15, which is going to end up with 1 divided by cos 39. And the reciprocal of cos, we say that is going to be sec. So 1 out of cos 39 is the same as sec 39 degrees. Now the same thing we do here. You find which expansion is this. I told you to find that an expression has to be compressed. You look at whether the angles are repeating. Now once you realize they are repeating, you compress them. Now this is going to be 75 minus 60, and you're going to end up with 15. Now the same thing you do here. 1 is the same as tan of 45, which you also substitute in the denominator. But which expressions give you this? Now since we're having a minus here, this is the same as tan a minus b, and our is 45 and our b is 15. So we shall say that this is going to be equal to tan 45 minus 15. Then you're going to end up with tan 30. In the table are going to be proofs. Now proofs are the same. So you're going to be proving Roman number 1. If alpha tau A, B, and C are going to be angles of a triangle, then you also prove this. Let's start with Roman number 1. So solution, first of all, whenever you say compounding expression, you start by expanding according to that expansion. Now it's advisable to use brackets so that you can easily make your work accessible. Now you find that cos A sin B, this is positive and it's going to go with this negative cos A sin B. And this expression is also the same as this one, and they're added by an addition sign. So it's going to give us what they're requiring us to prove. The proofs are always going to be simple and direct. You just need to expand. After expanding, make sure that you use brackets, because if you see this negative here, for someone who has not used brackets, it won't affect this sign here, which is very wrong. So whenever you're expanding, always use brackets. So expanding, this negative cos A cos B is going to go with this cos A cos B. Then you're going to have sin A minus sin B, which is negative, subtracting negative sin A sin B, and then you're going to get to end up with negative 2 sin A sin B, which you write as your final answer here. Tan A plus tan B, tan A tan B can be written in the form of sin A divided by cos A divided by also tan B can be written in that form. You find LCM, then you compress this. Now notice that these ones can always be presented in terms of proving, then you're going to end up with this. Now since these ones are angles of triangles, we expand it in this form, and then you reach out your final answer as this. So since I've talked about most of these ones, I'm just leaving out these because I've talked about all of them. So it's about you taking notes and trying to see how I came up with each of them. Everything is already explained. So you pause the video and you take the notes. They have told you that all these angles are acute. Show that without using tables or calculators that tan A plus B is equal to that. Now since you're having two angles, that means that you have to get both tan A and tan B separately. Then you are supposed to expand this one by a compound angle, and then you substitute. So you sketch. Since you're having acute angles, you draw your sketch. My sketch was this one, but it's not supposed to be like that. Your sketch is supposed to be in that form because it's lying in the first quadrant. But the labeling is going to remain the same. Now for the sides that are not given, now I'm having two sketches because I was given two angles, just like I explained previously. Then you find out tan b, which is going to be root 8 divided by 8. You also find out tan a. Now for tan a, I think it's this, and tan b is this one. Do here is substitution. Now substituting, you just substitute the values, just like we have handled them in the previous videos. Then further simplification must bring you here. So you pause the video and you take the notes for that. To the end of this video, it has been presented to you and compiled by Walgenbe Yusuf, and you're advised to reach out to this number in case you're having any inquiry about chemistry or mathematics. So see you in the next video, and for those ones having exams, success in your papers.